sure who came up with the mini STX form factor, or how it evolved from Intel's 5x5 format, or if it did, but regardless, ASRock put it on the map. When it did, this form factor was tantalizing for us small form factor modders, and many unique projects were born. Over the years, I would try to create various systems around this form factor, but there was one idea that I always wanted to try, but would always give up on: the piggyback idea. Please comment below with a better name, but the concept is really simple. Take a really giant graphics card and slap a mini STX motherboard to the back of it. I wanted the design to reflect the simplicity, and looking at the finished product, it's hard to believe that it took so much time, especially because it revolved around the sheet metal and not the layout. Layout is generally what takes me the longest when I'm doing these custom builds. NFC stands for not from concentrate, because my main goal when doing a design is to try something new and arrange hardware in a unique way. This layout was really easy this time, and I had it done in a couple of hours. And to be honest, the couple of hours part was just deciding where I wanted my power supply to go and what I wanted my power supply to be, but I even had a pretty good idea of what that was gonna look like. But man, figuring out that sheet metal. I want as little of a case as possible to be showing. I want it to be all about the hardware, particularly the beautiful and massive Sapphire 5700 XT Nitro Plus. I finally figured the best way to showcase the GPU was to directly bolt a skeleton to the backplate. Remember, I didn't know how I wanted the system to stand. I didn't know where or how I would make the flange or what it would look like. I tried dozens of parts before I landed with this. The flange doubling as the mount for the Pcie riser / adapter, as well as an attachment point for the stand. The stand of the build was much easier and took far less time. The main challenge was how to make it as smooth and small as possible. Originally, I was going to have it on the inside of the skeletal flange to make it skinnier, but I realized it would look far cleaner to flush rivet it to the outside. I messed with the curves a bit and got this really nice cascade effect from one part to the next. Finally was the base, which started out super simple, but later became a saga of its own. Instead of being super fancy and hiding the stand leg in the base of the wood, I opted to have the leg become a showpiece, and embedded it, which solved a lot of problems I had with the Q1 project in this series. With the concept in the computer and it looking pretty good, it was time to prove that this system could work. Now there are some obvious challenges with this build, namely there's no 16x PCIe slot for the Sapphire Nitro Plus. Secondly, there's no pinned power header on this board, only the 19-volt DC inlet. Maybe it's 12 to 19, but you know, I wasn't gonna blow it up to find out. The ASRock A300 is so cool because it has two M.2 PCIe slots, so I could run an NVMe drive and use a special riser adapter from ADT. They make some of these that are easy to get a hold of, but for the orientation of my board and GPU, I need to special order something. These risers are unpowered, by the way, and that was a problem that was gonna need to be solved. At this point, I basically had 3 devices that needed power. The recommended motherboard input is 19 volts, the riser ribbon is 12 volts, and of course the graphics card is 12 volts. I could run a separate buck booster to convert 19 volts to 12 volts, or I could just use 2 power bricks, but both of those are messy solutions, and I want something much cleaner. This is where the Compact Dynamo 360 comes in. This is an unobtainium power supply which takes 19 volts, converts it to 12 volts, but also has a 19 volt output which can be used to daisy chain another power supply, or make a custom pigtail to plug into the back of my ASRock A300. Now making the pigtail was easy, but finding a high quality jack was very difficult. I found plenty that were almost the right size, but none that were quality and the right size, so I kinda had to settle. With the proof of concept working, I was free to decide on coolers, and I quickly realized I wanted something maximally low profile, almost 1U, and I knew exactly what I was going to use: the Zalman CNPS2x. Unfortunately, it's an older cooler and isn't compatible with the AM4 socket out the box, but someone on my Discord, which you should check out by the way, pointed out that there is an AM4 adapter bracket kit. But the problem with this adapter kit is that it's very poorly made, and the standoffs are not the right height to actually get any kind of contact with the cooler and your CPU spreader. So I actually had to take the standoffs and go sand them down until I got a good contact. So the CPU I tried first was the AMD Ryzen 7 3700X. which did not work in this motherboard. There wasn't a BIOS update for it yet. Not only that, the motherboard I don't think liked the chip. That or I did something stupid, which isn't out of the question. Either way, I had a dead, smoking motherboard and needed to find a replacement. But at this point, they were all out of stock, so I had to go to eBay and beg for one. Now what you're watching here is an episode of a season of which there are now 4 of that I do for Sapphire. And the point of all that is to say that most of the time I cut out the metal for these builds by hand, but this time I tried something different. Now I have the ability to cut metal out with my CNC laser or my CNC router, but you guys have complained an awful lot that I have too many tools or take way too long to do stuff by hand, and you want a solution that you guys can employ. So I tried out SendCutSend, which is an online service where you submit your DXF files and you get back your 2D flats, all nice cut and wrapped for you. I'm not sponsored by them yet, but I am sending them an email because I would love to work with this company. Anyway, my original plan was to polish this aluminum, so I started sanding it to prep it, but about halfway through I decided that I actually wanted to paint it this time. My electromagnetic brake is still working for me, but these parts are so simple they could be bent on a budget DIY option. Use YouTube to get some ideas. One thing you might wonder is how to know where to bend your metal. I use Fusion 360 to model my parts, and in sheet metal mode, I can build a part, then press a button and it unfolds flat and has marks where the bend lines are. I am oversimplifying as there are some rules you need to input and consider, but overall, it's pretty easy. There are so few parts that after bending, I was nearly done with the frame. I knew I wanted flush rivets so the visible side of the stand was smooth. I marked my metal, set the stop on my drill press, and I had the holes which to rivet my parts together. The last part I crafted was the base. I went with Purple Heart because it's pretty much the motif for these Sapphire NFC videos. Now this stuff is hard, really hard. It sounds like ceramic when knocked together. I probably will have to turn that down in post. Luckily, I already know the speeds and feeds for this wood from my router, so that part was pretty easy to program, but I didn't do a good job securing the material to the bed, and I had a machine crash and broke one of my end mills. I gave that piece to a souvenir as a friend, and round 2 produced my final part. Yeah, at least I thought it was final. You see, when I had this whole thing assembled, I found that my bend for my stand was just a slight bit off, but that offness got amplified because the build was so long, or tall rather. So that meant I had to go back and modify my base on the router. Now I figured out how to machine the slope on the part, but getting it fixtured was much more challenging. I had everything all set up, but when I ran the operation, my machine didn't have the clearance I thought it did, and I ended up damaging my part.
Oof.
Now fixing it meant that I had to make my base much thinner than I had planned, and although it was very scary because I thought it was going to end up machining into the tool steel vise, I just barely squeaked by. And machinists out there are going to criticize me, but that's also fine because again, if you want to volunteer, I have plenty of parts that you guys could make me. Now my base is finally finished, and I want to show you all something really cool. When you first cut Purple Heart or sand it, it has a reddish brown hue, but if you leave it in the open air, it oxidizes and turns super purple. Check out the difference a day makes on the shavings alone. The longest part of crafting was the paint process. It was the hottest and most humid time of year, and I don't have a climate-controlled shop, so I'd use tons of coats on each product because the paint was drying before it hit the metal. The products I used were a self-etching primer, direct metal primer, a metallic base coat from House of Color, and the 2K Clear from SprayMax. I also purchased an adhesion promoter for the 3D printed parts, but decided to leave them natural because Markforged Onyx looks great as is. It took me 3 days to paint this, and in between sanding jobs I would take pictures and admire the progress, or curse the progress. I'm sure there's a pro painter watching this with lots of criticism, and that's fine. You are totally welcome to come paint my mod next time. While I waited for the paint to dry, I worked on the Pcie slot cover, which makes this build oh so much neater, and also doubles as the mount for the on-off switch. This part, along with various washers and spacers, was printed out of Onyx on Compact's Markforged printer I have out on loan. Onyx is a very strong, heat-resistant carbon fiber plus nylon mix. I ran into problems with the assembly, which was expected, but the problems were not what I expected, which also was expected. Anyway, the fitment of the parts was spot on. The skeleton's bolt holes lined up perfectly with the GPU's backplate threads, and my custom washers and spacers made everything look very professionally engineered. Where I was noticeably not professional was that this board was not working with the 3700X anymore, and neither was my GPU. These were two separate issues, but it took a couple of days of tearing my hair out working with the multimeter to diagnose my problems. The GPU problem I solved, and it had to do with my custom PCB 180-degree connectors. I think I had a bad one. Anyway, that was working now, but the CPU still wasn't. So I decided to try a different CPU, the Ryzen 2400G. At first I was kind of disappointed because I wanted to use the 3700X for this build and not the next one, but there were two ideas that popped into my head that made it much more interesting. Firstly, the 2400G is a natural stepping stone, I think, for some people who might want to purchase just the APU to save some money, and they can play all esport games and indie games, and even AAA games with the graphics turned down a bit. But those people might want to upgrade to a big beefy GPU at some point, and they want to know how it's going to perform. The second reason I was interested is that this motherboard has an option, actually two options, for switchable graphics. So now the system can stay super quiet and chill, and then kick in with one heck of a turbo with this beefy GPU. Of course, the Nitro Plus is already super power efficient at idle, and it can even operate with its fans off. Even when gaming, the fans are quiet because the massive heatsink keeps the card really cool. Really, there wasn't much to the assembly process for this build. All the wires were made one at a time to make sure they bent perfectly, and I did cut a piece of thermal padding the Dynamo unit to run the cables neatly behind it, but it went together really well. The last step was to put some epoxy and mix it up on the base, and with that, the system was assembled. Testing went well. The system was peaking around 370 watts and running all my games at playable frame rates at 4K. Some settings did have to be tweaked here and there for more intensive titles, but the 5700 XT Nitro Plus does a great job for real-life gamers. I find that it balanced performance and visuals perfectly for me. In fact, I run a 5700 XT in my main rig. Now, the one game I want to test the most on this rig, and couldn't, was Microsoft Flight Simulator 2020. I've had problems installing or launching this game since day one, so if you guys have any information on how I get this game working so I can play it again, please send me an email. I'm naming this build Project Ionic. Ionic from the classical order of architecture. The build is simple but tall and elegant at the same time, like an Ionic column. Someone might argue that Project Doric might be more suited, but that doesn't sound as cool. To wrap this up, I want to stress that I don't consider myself a good designer, an engineer, craftsman, or technician. I'm just a guy who loves to make unique computer system builds and share my adventures with you all. At the very least, hopefully this video inspires you to think outside the box for your next PC build. Thanks to Sapphire for providing the 5700 XT Nitro Plus for this build, AMD for providing the CPU, and you all for watching it. And finally, a very special thanks to my Patreons. As always, the 3D files I use to make this project are available to you patrons. Sapphire AMD wants to give away Project Ionic to one of you guys. To learn more, just click the links in the description. But this video is now over, and that was episode 3 of season 4 NFC, brought to you by Sapphire and AMD. And not from Concentrate, just kind of get my own little plug in there. Everybody, peace.